Welcome to this Monday morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to review for the Chapter 10 test. And to start with, I have some questions that were emailed to me. And this is, let's see, this is from section 10.4. And we're going to start off with number 9. And it basically says to graph f of x equals 1/3 x squared. And let's switch colors here. G of x equals negative 1/3 x squared. We're going to graph both of those on the same graph. So let's take a look at the first one, f of x equals 1/3 x squared. And I'm going to use, let's see. Oh, well, where would the vertex be on this thing? It would be at 0, 0, wouldn't it? Okay. Any questions about that? Well, there's nobody here to ask questions anyway. What if x is 1? F of 1 would be 1/3 times 1 squared, which is 1/3 times 1, which is 1/3. So over here on the graph, turn that blue, graph the vertex first, and then 1, 1/3. Now, when I try to do that, it doesn't like me. So I go over here and I change that to 1, 1/3. Okay, so there's f of x equals 1/3 x squared. Now, I'm going to graph the red function. Unfortunately, in WebAssign, I don't know of a way to change colors of the graphs, but we'll do the best we can. So this one, the vertex is also at the origin. And if we let x equal 1, we get g of 1 equals negative 1/3 times 1 squared, negative 1/3 times 1, negative 1/3. So coming over here, turn it blue, I've got 0, 0, and 0, negative 1/3. Again, I need to come in and fix this. Negative 1/3. And there are the two graphs of these things right here. Okay. All right. Let's take a look now at number 19 from that same problem. And keep in mind that I'm not graphing the one that you see there that says negative the quantity x minus h minus 8 squared. I'm graphing a different one. Okay, so let's turn this black again. And this is still 10.4. This is number 19. It says f of x equals 1/8 times the quantity x plus 1 squared minus 3. They want the vertex, the axis of symmetry, and the graph. Okay, so the axis of symmetry is at x equals h. H in this case is negative 1. So it's at x equals negative 1. So over here, I'm going to put in x equals negative 1. Notice it is an equation. The vertex is at negative 1, comma. let's find out what f of -1 is. It would be 1/8 times -1 plus 1 squared minus 3, which is 1/8 times 0 squared minus 3, which is 0 minus 3, which is -3. So the vertex is at, come on, where's the mouse? There it is. -1, comma, space, -3. All right, now, so to graph it, my vertex is at -1, -3. Okay, and then I need a second point. So for my table, I've got -1, -3. How about when x is 0? Let's find out what f of 0 is. That's 1/8 times 0 plus 1 squared minus 3, 1/8 times 1 squared minus 3, 1/8 times 1 minus 3, 1/8 minus 3. Okay, so 1/8 minus 3 over 1 is 1/8 minus, it won't let me write there. Okay, fine. Let's see, let's go over here. 1/8 minus 3 over 1 is 1/8 minus how many eighths? So I got to multiply by 8/8 minus 24/8, which is -23/8. So my second point is 0, -23/8, which is almost -3, is right about there. But here's what I'm going to do. Go in here. Okay, -1, -3, 0, and then -23/8. So there is the graph. Okay, now let's see here. I'm going to change screens for a minute. So we'll go here and give me just a minute. Okay. Hang on, I'm getting there. This is 10.4, number 19. Oh, not number 19. We already did that. Number 34. Okay. So now, again, this is 10.4, number 34. It says, from the top of the building, a ball is thrown straight up with an initial velocity of 32 feet per second. The equation S equals -16t squared plus 32t plus 48 gives the height S of the ball t seconds after it is thrown. Find the maximum height reached by the ball and the time it takes the ball to hit the ground. Okay, so our equation is a second degree or quadratic equation. The leading coefficient is negative, so the graph would be a parabola. Okay, where this variable is time and this variable is the height above the ground. It says find the maximum height and the time it takes for the ball to hit the ground. Well, the maximum height would be the S value of the vertex. So even though our variables are t and s, I'm going to think in terms of x and y for the moment. So for this quadratic equation, A is -16 and B is 32 and C is 48. So if we use x equals negative b over 2a, we get negative 32 over 2 times negative 16, which is negative 32 over negative 32, which is 1. So what does that say? That says that the ball reaches the maximum height after 1 second. What is that maximum height? Well, that would be when t is 1. S equals negative 16 times 1 squared plus 32 times 1 plus 48, which is negative 16 times 1 plus 32 plus 48, which is negative 16 plus 32 plus 48, which is 64. So the vertex is at 164, but it says find the maximum height. So the maximum height is 64 feet. Okay, so that's this answer right here. Now, then it says the time it takes for the ball to hit the ground. Now, the ball reaches its maximum height in 1 second, but that's not what they're asking for. They want to know the time when the ball hits the ground. Oh, well, that would be an x-intercept, wouldn't it? So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 32 plus or minus the square root of, let's see here, 32 squared is 1024. And then we've got negative 4 times negative 16 times 48, which is plus 3072 all over negative 32. X equals negative 32 plus or minus, let's see, 3072 plus 1024 is 4096 all over negative 32. 4096 is a perfect square. So x equals negative 32 plus or minus 64 over negative 32. Okay. So let's see here. Let's take this to the next page. X equals negative 32 plus or minus 64 over negative 32. Is that right? Yes. So x is negative 32 plus 64 over negative 32. Negative 32 minus 64 over negative 32. Well, this top one would be 32 over negative 32, which is negative 1. This bottom one would be negative 78, negative 96. How about that? Over negative 32, which would be 3. So x is negative 1 and x is positive 3. Well, when it hits the ground, couldn't be a negative time. So what is that x equals negative 1? That's this value over here, but the ball started up here on top of the building, okay? So graphically, you'd have a negative 1 x-intercept, but that's not a solution because you can't have negative time. So the correct answer would be t equals 3 seconds, okay? Which would be right here. Now let's take a look at number 37. So this is 10.4, number 37. The total annual enrollment in millions in a country's elementary and secondary schools for the years 1980 to 2001 is given by the model E of x equals 0.058 x squared minus 1.162 x plus 50.809. X equals 0 corresponds to 1980, X equals 1 corresponds to 1981, and so on. For this period, when was the enrollment the lowest? Okay, if we were to graph this function, the leading coefficient is positive, so the graph would be a parabola opening upwards. Okay, this variable would be X, which would be the year. This variable would be E, which would be the enrollment. So they want to know for this period, when was the enrollment the lowest? And then what was the enrollment? So basically we need to find the vertex. Okay. A is 0.058. B is negative 1.162. X equals negative B over 2A is negative times negative 1.162 over 2 times 0.058. Negative times negative on top is going to be positive 1.162. And 2 times, hang on, 2 times 0.058 is 0.116. If we take 1.162 divided by 0.116, we get 10.01724138. Okay, now it says for this period, when is enrollment the lowest, round your answer to the nearest year. So rounding this to the nearest year, that would be 10 years, right? So X is 10, but recall that X equals 0 corresponds to 1980. So X equals 10 would correspond to 1990. So when was the enrollment the lowest? 1990. We'll say lowest enrollment. Now, what was this enrollment? It says round your answer to 1 decimal place. So do I want to take this whole nasty number and plug it in here and here? I don't think so. Let's just take, it says our answer is going to be to 1 decimal place. So if we started with our numbers to 1 decimal place, 10.0, so I'm just going to put in 10. So E of 10 is going to be 0.058 times 10 squared minus 1.162 times 10 plus 50.809. And let's go to the calculator. 0.058. Oops, clear. 0.058 times 10 squared, which would be like times 100, minus 1.162 times 10 plus 50.809. And I'm coming up with 44.989, and it said round to 1 decimal place. Well, rounding to 1 decimal place, the 8 would round up, turning this 9 into a 10, which would actually be 45. But since it's said to do 1 decimal place, it would be 45.0 million students, which is what we have right there. Okay, so now, hang on, I'm going to switch some information around again. We'll go back to the white screen, and we're going to look at a chapter review question. This is number 33. Let's see here. Yeah. Okay. So this is the chapter review number 33. A fireworks shell is shot straight up with an initial velocity of 120 feet per second. Its height, s, after t seconds is given by the equation s equals 120t minus 16t squared. If the shell is designed to explode when it reaches its maximum height, how long after being fired and at what height will the fireworks appear in the sky? Okay, so first of all, let's write this equation in standard form. Okay, we see that A is negative 16, so this thing is a parabola opening downward, and the vertex would be, let's see here, T, S, where T would be the time it takes to reach its maximum height, and S would be the maximum height. So we've got A is negative 16 and B is 120. X equals negative B over 2A, which is negative 120 over 2 times negative 16, which is negative 20 over negative 32. And negative divided by negative is positive. 120 divided by 32 is 3.75, and that's seconds. Okay, so how long after being fired? The time would be 3.75 seconds. And then what is that maximum height? So up here we've got 3.75. We put 3.75 in for time. S equals negative 16 times 3.75 squared plus 120 times 3.75. Calculator time, negative 16 times 3.75 squared plus 120 times 3.75, and I get 225. So that would be 225 feet. So that would be the maximum height. All right, so that concludes the questions that students asked. So now I'm going to once again change the screen and just share the white screen, whiteboard. Give me a minute here, and we'll get back to normal, so to speak. Okay. All right. So in this chapter, section 10.1, we have the square root property. Square root property. The idea was that you took the square root of both sides of an equation, but before you did that, you wanted to have a perfect square containing a variable on one side of the equation and a constant on the other. So for instance, let's take this example, u squared minus 24 equals 0. So we'd start by adding 24 to both sides. U squared equals 24. So now we've got a perfect square on the left containing a variable and a constant on the right. Taking the square root of both sides, don't forget the plus or minus. U equals plus or minus the square root of 24, but we can simplify that into 2 square roots of 6. So u equals plus or minus 2 square roots of 6. Recall in WebAssign, you'd have to write those as separate answers separated by a comma. Then in section 10.2, we had the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, too many c's there, sorry about that, all over 2a. Okay, you should have that formula memorized. You use that to identify a, b, and c, plug them in, simplify, get your answers. 10.4, we had y equals a times x minus h squared plus k. When the second degree or quadratic formula was in this form, if a was greater than 0, it opened up. If a was less than 0, it opened down. The axis of symmetry was at x equals h, and the vertex was at h. Okay. Keep in mind, the axis of symmetry is an equation. Don't just put a value, put x equals that value. Then the second part, y equals ax squared plus bx plus c. Here, if a is greater than 0, it opens up. If a is less than 0, it opens down. The axis of symmetry is at x equals negative b over 2a. And the vertex is at negative b over 2a comma, and then you plug that value into the function to find the corresponding y value, okay? To find x-intercepts, set y equal to 0. To find y-intercepts, set x equal to 0. Okay, and we went through an example of graphing in WebAssign here earlier. Well, that's all I've got to say. Since there's no one here, I don't know if you have any questions, but I'll be back at 1:15 with an office hour. And so with that, I will bid you adieu.